Just a moment. Okay, so it seems few of you are not able to hear. Just a moment. Okay, hopefully now you're able to hear. Fine. Okay, sorry. Okay, so that is the Binet software which is only required in the SMP, and whenever we have the MPP configuration, then only we go for the Binet hardware. So in a single system, when we don't have the Binet hardware, the PDE and the Binet software as a combination would perform all the Binet activities, that is the communication across the multiple components of a single node. And this is the actual configuration of the architectural components. Okay, we have seen yesterday we have two types of virtual processors. One is the PE and another virtual processor is called as an AMP. AMP is access module processor. PE is the parsing engine. Both are virtual processors, but they have defined characteristics, defined responsibilities to perform in the architecture. Okay, so we'll see that. Okay. And if you observe here, we have Binet, and there are two components of Binet and which are redundant. You have Binet 0 and we have Binet 1. Okay, why we have two Binets? Okay, it is a single node. Okay, before going into it is a single node, so we are looking at a single node configuration of the components, how they would be arranged, okay, in a single node. Okay. So we have the PE, the parsing engine, we'll see, and we have the Binet. So Binet is with a combination of two redundant components, Binet 0 and the Binet 1. Okay, and then we have the AMPs, access module processors, and we have the virtual disks. Okay, so this is the final configuration what we have to understand in Teradata. Okay, we know each and every component individually. Okay, and now we are looking at the arrangement of the components in a single node. So we have, so now we'll focus on Binet first to understand. Okay, so Binet is to make the communication happen between multiple components in the architecture. So Binet exists in between the PE and the AMP. So Binet is responsible to make any communication between the AMPs and PEs. So PE is a virtual processor and AMP is a virtual processor. So to make this communication happen in between PE and AMPs, we have to have a Binet, and this Binet is of two components, Binet 0 and Binet 1. Both are same, with same functionality, same responsibilities, same characteristics. But why we have two? Here we have two Binets for the purpose of fault tolerance. Okay, both are individual. They won't depend on each other. Okay, they are independent, redundant components. Why we have two Binet components? Because of the fault tolerance technique. Yeah, so even one of the Binet is failed due to some reason, we still have another Binet available to make this communication continue. Yeah, that is the only purpose how Teradata has designed to have two Binet components which are redundant with the same capacity and same characteristics. Yeah, so it is one of the fault tolerance technique they have applied at the Binet levels. Yeah, so here the slide uniquely defines what are the features of the Binet. The first feature of Binet is the scalability. Whatever we say, the Teradata can scalable to infinite number of nodes, or in Teradata 14 up to 4096 nodes in specific. Okay, how we are able to say, because of the capacity of the Binet, how it can be scaled. So because of this Binet scalable, we can say Teradata is scalable. Okay. As you add more nodes to the system, the overall network bandwidth scales linearly. Okay? It is not that once you keep on adding the nodes, we are losing the bandwidth and we are losing the capacity of serving the customers. Okay? Once you add the node, if you add the bandwidth of the BiNet also by adding some more hardware and some more software combination of the BiNet, you are not going to lose your response time. Okay? You will be linearly improving the bandwidth of the systems. Okay? This linear scalability means you can increase system size without performance penalty. Okay? And sometimes if you feel that the current configuration is not up to your expectation, you may add only the BiNet and hardware and software combination so that it will improve the performance. Okay? Even though you are not adding new nodes, you may add the BiNet hardware and software combinations in your configuration so that it will improve the performance. Okay? And generally we go for this BiNet hardware and software installation whenever we have a new node to be installed to the existing machines. But yes, if you want to improve the current performance, then you can go for only the BiNet hardware and software installation so that it will improve the bandwidth and improves the response time. And then it has a high performance. Why it has a high performance? An MPP system typically has two BiNet networks. Okay, we have seen that we have BiNet 0 and BiNet 1. Okay, both of them would work when both are active. Okay. When both are active, the system would get the combined bandwidth of both the BiNets. Okay. So the aggregated bandwidth of the two active BiNets would be enjoyed by the customers when both are active. Okay. And it is fault tolerant because we have two redundant components. Even though one of the BiNet is failed, the other is available, so we can still continue the communication. If we have only one BiNet with the same capacity, so let's suppose it is 4 Mbps and it is also again a 4 Mbps. Okay. Instead of having two components, if I install only one component of 8 Mbps, then if something happened and one BiNet failed, okay, the single BiNet failed, then we may have to close the system. Right? So to avoid that process, they have divided the bandwidth and they have installed two redundant components so that even though one BiNet fails, another BiNet still continue the communications. Okay. And then out of these two components, they have an intelligence load balance. When requests are coming from the clients, the load will be balanced across these two BiNets to serve the customers. Okay, if one request is coming to BiNet 0, the another request will go to the BiNet 1 automatically. Okay. When BiNet 0 is very much occupied with the task, BiNet 1 will automatically take the burden from the BiNet 0 whenever it completes its own task. Okay. So then there is an intelligence and automatic load balance across these BiNets. Okay. So when both are active, you can get a high performance, the aggregated bandwidth of both the BiNets, and whenever one fail, you can still continue our communications, and they have an intelligence automatic load balance between them. Okay. And you can keep on increasing the performance by adding more BiNet to the existing system, or whenever you are going to add a new node, not to decrease the performance, you have to add the BiNet hardware and software also, so that it will improve the performance and the bandwidth linearly across all the system. So these are some specific BiNet unique features. Okay. So one question is how the performance is improved when we add the BiNet. Okay. Let's suppose this is a single node configuration. Okay. I have 100 users which are using this. Okay. So now I have improved my system with an MPP by adding two nodes. So the number of users got increased. Now there are 200 users. Okay. and I have 2 nodes in my MPP machine. So it is obvious that when 100 users use the system, they may got their responses within 1 minute, and when 200 users are using simultaneously the system, okay, how the performance will be improved. Okay, when I have 2 nodes, but I didn't improve the BiNet, let's suppose. Okay, I didn't improve the BiNet. I just had a BiNet hardware and software combination to make the communication between 2 nodes, and now 200 users are the clients. Okay, and later we have 400 users. So can I expect the 400 users also would get the same response time for the queries? No, because the number of users increased. So the burden on the system got increased because of the bandwidth. So when we have 8 Mbps BiNet and when we have 200 users, the average response time is 1 minute, let's suppose. Okay, and when we have 800 users and when we have the same configuration, it is expected that the response time may be decreased a bit, right? So to improve, so where is the bottleneck here? The BiNet, right? Because of the communication between the P and the amps. Okay, when we see the characteristics of P and amp, you will understand what their responsibilities are. But right now, if there are 200 users, the capacity of 8 Mbps would serve in a perfect manner. And when we have 800 users or 400 and then increase to 800, then the BiNet bandwidth is same, 8 Mbps. Then how we can expect all the 800 customers would be served in the same manner when they are simultaneous users? Okay, so how we can improve that? You can install the BiNet software again and the BiNet hardware also with the more cables between the MPP systems. Okay, so that you can improve the bandwidth. Okay, how we are improving our broadband bandwidth? Okay, I'm improving to 2 Mbps to 4 Mbps, 4 Mbps to 10 Mbps. Okay, so in the same way, we can connect cables and we can improve the optical fibers within the cables so that the bandwidth will be increased and the 800 users can now get the same response time. How? When there were 200 users. Okay, that's how we can improve the bandwidth of the BiNet. Okay, similar as our broadband bandwidth improvements, so that it will serve more customers with the same speed. Okay. Okay. So we have seen the BiNet features, okay, the BiNet uses, and when we have the BiNet hardware and when we don't have the BiNet hardware. And these unique features in turn become the Teradata unique features. Yeah. So we'll see the Teradata features also, but these are the features of the BiNet which gives, okay, the unique features of, okay, which will be inherited to the Teradata also in terms. Yeah. And now this is the actual architectural diagram, okay, where we are going to see each and every component's responsibility. See, this would improve based on the current configurations. Okay. Okay, I have some questions. Let me clarify those and we'll move forward. So this is a node actually, and yesterday we have seen the node components, right? So yesterday I have explained each and every component, and when if you didn't attend it yesterday's, yeah, I will take some backup sessions who didn't join yesterday's one, and I'll explain you what is the node and what are the node components. Okay, and at max how much bandwidth we can add BiNet between nodes. Okay, it is not specific right now. It may improve based on the configuration of the Teradata server. Okay, how we are improving our processors from i5 to i7, okay, P3 to P4, P4 to i3, i5, i7. Right now, okay, Teradata is having 4096 nodes can be combined, okay, with almost 20 Mbps speed. Okay, so this is the current configuration at the research and development of Teradata. It is not yet installed. the Teradata 14 with the 4096 nodes, it is not yet installed. So it is the highest configuration available in the world right now from Teradata. Okay, so it could be 20 Mbps bandwidth you can maximum add between the nodes. Okay. Any other questions, anyone? Up to here, the architectural components, the node, the binet, the characteristics of the binet. Let me unmute you all. We'll have a small break and we'll continue. Any other questions, anyone? Okay, good. So let's go ahead. See, the communication performance is improved through binet. The communication, whichever happens within the architectural components, is improved by the binet, and the auto traffic, auto balance would also happen within binets. Okay, right now we are focusing on binet. There are other improvements, other opportunities, okay, where we will be finding in the parsing engine, amps, everything. Okay, right now I'm focusing on binet, which is the first component of the architecture what we have to understand. Okay, when we increase the multiple nodes, then we are automatically increasing the processors also, right? We have seen the demo, okay, where we are improving the processors, the memory, the hard disk memory, where we will getting multiple virtual disks, and along with this, if you improve the bandwidth also, then it will show you the correct performance, right? So I hope you understood. We improve the CPU also in Teradata architecture, right? So in the normal traditional system, we cannot improve the CPUs, but here in Teradata, we can improve the CPU also when we are installing multiple nodes in our configuration. Okay, when we have multiple nodes, we are improving the CPU along with the memory, and then the communication across the virtual components also with the help of binet. Then we will have a complete improvement in the performance of the communication and performance of the processing, performance of storage of the data, everything. No. Okay, I will come back to you. Once we complete the whole architecture, most of your questions will be cleared, and still if you have any questions, we'll discuss that. Okay. So right now I'm focusing on binet. So binet is to improve the communication between the architectural components. Okay. And we have the other components, and when I say MPP, it is multiple nodes, so automatically I'm improving the CPU and the memory, and it is not only enough to improve the processing and memory, it should be improved in terms of the bandwidth in the communication also, so that we can get a perfect linear scalability of the system. So there is no bottleneck here in Teradata architecture where you can improve all the terms, the CPU, the memory, the bandwidth. Okay. So now we'll move ahead to understand the rest of the architectural components responsibilities. Okay. So when you see the SQL request would come to a node, so let us assume it as a single node configuration. The whole thing is a single node, and within this node we have the parsing engine, that is PE, a virtual processor, and then we have the message parsing layer, that is the combination of PDE and the binet. Okay. And we have AMP as in another virtual processor, access module processor, and this AMP, the virtual processor, is associated with its own dedicated virtual disk. So this is the virtual disk. Okay. So once an SQL request comes from the client, okay, let's suppose I am the customer, okay, I am executing a query like select star from employee. So that is the SQL request here. And this SQL request is served first through the parsing engine. Okay, when I say parsing engine, It is a virtual processor, and within the parsing engine we have three other subcomponents. Okay. So first one is the parser. What it does, within the parsing engine we have the first subcomponent called parser. Okay, as its name indicates, what it does, it will parse the SQL which is given by the customer. Okay, what is the SQL? Select star from employee. So first it will see whether we have given a proper syntax in the SQL or not. Right? RDBMS can only understand the SQL language, structured query language. It won't understand any other language. So the parser will verify whether we have given the request in a proper syntax or the semantics. Okay, when I say syntax, the spelling in the query, the order of the predicates in the query, everything is verified by the parser. Okay, let's suppose if I give a spelling mistake like SLECT, so it won't understand. So who will throw the error? That is the parser. Okay, so parser will verify all the spellings, the syntax, the semantics, like semicolon should be there at the end of the query. All these rules would be verified by the parser first. So once the parser is satisfied with the SQL, okay, he has given a proper SQL with the proper spelling and correct keywords with the semicolon at the end of the query, then it will start identifying the objects. Okay, once the syntax is verified, it will verify for the objects what you have referred in the query. So what is the object I have referred? Employee. So it will see whether this employee table really exists in the table or not, in the database or not. Okay, if the table name is not there, then again it will throw an error, the object not found. If the object is already there, then it verifies the access rights of this user on the object. Okay, I have given a proper query, I have given a proper object in the query, but let's suppose if I don't have access on the employee table, then what happens? Okay, it may throw an error, the user doesn't have access, select access on the object. Okay, so like that it will verify the query in terms of syntax and semantics, and then it will verify the object existence, and it will verify the access rights of the user on the object. So all the aspects are verified at the parser. So once parser is satisfied with all these terms and conditions, rules and regulations, then it will give this SQL to the next component called the optimizer. What an optimizer does? Optimizer will verify the query and see how many number of steps are required to execute this SQL. Okay, for us at a high level language, the select star from employee is a single statement, but in terms of executing this, the RDBMS has to do several steps. For example, select star from employee, I have given the simple query. So in order to execute it, first the RDBMS has to lock the table for the read purpose for this user, and then it will see if there are any conditions in the query and fetch the records and put it in a temporary memory. And then if you give any aggregations, if you give any sorting orders, then it will perform all those orders, aggregations in the temporary space of the memory, and then finally it will give the results to the users. So these are the internal steps it has to perform. So first locking of the tables, and then fetching the data into a temporary memory, and then massaging the data as per your conditions, as per your aggregations and the ordering rules, and then finally give it back to the users. Right? So what optimizer does, optimizer will divide this SQL into executable steps. Yeah, RDBMS executable steps. And it verifies, are there any other ways to execute the SQL with minimal resources? Okay, so we may write different SQLs for achieving a single functionality. Right? We have a distinct and we have a group by. Both are achieving same functionality in terms of getting distinct records. But which one is better? Okay, we have to do some analysis and we have to find out if the data is more, this is good, and if data is not more, this is good, if duplicates are more, this is good. So all these things we do generally while writing the SQL. After we write the SQL, optimizer also has some intelligence to understand and to optimize the SQL within it, so that it will find out, okay, what are the ways of execution of these steps and which way is the better way to execute this SQL with minimal number of resources in terms of CPUs, in terms of IO, okay, input output operations. It will verify which way of execution is optimized way, and that way of SQLs will be given to the dispatch. Why it has to give to dispatcher? Because the executable steps which will be identified by the optimizer will be executed by the AMP, the access module processor. So this is only a thinking processor where it will verify all the SQL rules and regulations, syntax, semantics, existence of the object and access rights, everything it will be verifying. And then optimizer will see what are the number of ways of execution of this SQL, what are the number of executable steps which are required by the AMP finally. Okay, that is what the responsibility of the optimizer. What it does, it will divide the SQL into executable steps by the AMP. So this parsing engine won't execute those executable steps. It just says what to be executed in order to serve this query. And once it has come up with the optimized way of execution of this SQL, it will give it to the AMP through the dispatcher. So the dispatcher, as its name indicates, again dispatch, it dispatches this set of executable steps to the AMP. How it dispatches? In between these two components, that is the parsing engine and AMP, we have the message parsing layer. Okay. PDE, the combination with Binet software. Okay. So message parsing layer will have PDE and Binet, okay, which improves the communication between the parsing engine and the AMP, okay, and which enables the communication between these. So the dispatcher of the component, okay, will give the SQL, the executable steps, to the AMP. Okay. And this AMP will perform all those steps on its own associated virtual disk. Okay, so whatever query you have given, the query will be executed by the AMPs on their own associated virtual disks, and AMP will get the data out of the virtual disk and again will give it to the message parsing layer. And this message parsing layer will merge the answer sets given by the each AMP and give it back to the user through the parsing engine. Okay, so this is the complete communication what would happen when we have a SQL requested by the customer. Okay. So what happens when SQL comes, it will go to the parser, verifies. Okay, before this, okay, we have session control also, but in some of the books, okay, we may not see this. The session control is to validate whether the user ID and password what he has given to log into the system is valid or not. Okay, in some technical books it is not mentioned because this is the controller, the session controller would happen even before the SQL request. Okay, so even you have the credentials to define the SQL request, the session controller would do the validation of the user ID and password. That's where again some of the books, to avoid the confusions, they have removed it. Again, in older books we used to have session control, but for new users you don't confuse. These are the components. Okay, to avoid such confusions, okay, we have only the parser, optimizer and the dispatcher. Okay, before SQL request there would be another component called session controller, which is part of the parsing engine. And again, when we are moving towards, you will see some more components of the parsing engine. Okay, but for now it is enough to understand only these components. Okay, I will walk you through the other components of the parsing engine and other components of the AMPs also when we move towards data distribution and when we are moving to the utilities. But right now, okay, this is the architecture. What we have to understand, we have to have the base understanding of this architecture. Okay, whenever we have the SQL request, it will go to the parsing engine, and within the parsing engine we have the parser, which validates the syntax and semantics. Okay, I have mentioned it here. Okay, it manages the individual sessions and parsing and optimization of the SQLs, and finally dispatching the optimized plan to the AMPs through the message parsing layer. Okay, so sending the answer set response back to the request client. Okay, so these are the responsibilities of the parsing engine. Okay, and then once the steps are created which are to be executed, then it will go to the message parsing layer. So message parsing layer, what it can do, it carries messages between AMPs and PEs, and this message passing layer can do multiple types of communications. Okay, when we say point to point, that means one component to another component. Let's suppose if optimizer decides this particular SQL to be executed by only the AMP number 2. Okay, so that is the decision of optimizer, that all this SQL should be executed by only AMP2. Then it instructs the message passing layer to dispatch this message to only AMP2. So message passing layer can do that. That type of communication is called as point to point. Okay, one component to another component. Okay. And if optimizer decides this particular SQL to be executed by AMP2 and AMP3, then message passing layer can do that. Okay, it can provide the message, dispatch it to AMP2 and AMP3. So this type of communication where one object to multiple components, one component to multiple components, it is called as a multicast communication. Okay. And when optimizer decides this particular SQL to be executed by all the AMPs, then message passing layer would do a broadcast of the message to all the available AMPs. Okay, so it can do a broadcast communication also. Okay, so it can do a point to point, a multicast, and a broadcast communications. Okay. And what is the other responsibility of message passing layer? Once the AMP performs all the physical operations on the data, and when it gives back the result set, it will merge the data of all the AMPs and give it back to the answer sets. Okay, so it will merge the answer sets back to the P. Okay, so because of this message passing layer, the Teradata parallelism is very much possible. Okay, so here this is the thinking processor, thinking virtual processors, you can say. So it will think about the SQL, about its rules and semantics, and then optimize it, and it will identify how to execute this, and it instructs the all other components what to do. And who actually does this work? The AMPs. Okay, what AMPs does? They will do all the physical operations like access storage using Teradata files. Okay, and it will do the locking management if multiple users are using the same table for different purpose. Okay, we have to have the locking management. So it would do that. And if you use a order by clause, it would sort the rows. If you use any aggregated functions like sum, maximum, minimum, then it will do the aggregations. And if you join multiple tables in a single SQL, it will physically join the answer sets of both the tables. And if you format the output with some beautiful designs like casting, get data type conversions, or padding some extra zeros, padding some extra spaces, if such type of requirement is needed to generate a simple report, it will do the physical conversions and formattings, and then creates answer sets for the clients, how they requested, in which format and which data type they requested. It will convert all the results into the required answer set formats. And then disk space management, accounting. Accounting is a concept in giving priorities to the users. Okay, some users may be having high priority to execute the queries. Some users may have less priority to execute the queries at that particular moment. So the AMPs will see the accounting of the users, and it will give the proper priorities at proper times for execution of the SQLs. Okay. And it may use special utility protocols when we use the other utilities like fast load, fast export. This is the component which serve the purpose of execution of the utilities. Okay. And whenever we do an archival and recovery processes, only the AMPs are involved in restoring the AMP level archivals. Yeah, so these are the typical functionalities of the AMPs. So all physical operations, okay, in a single word, what we can say, AMP will do all the physical data operations which are instructed by the parsing engine. Yeah, so these are few of the physical activities that a AMP will do on the data and in its own associated virtual disk. Okay. So these are the major architectural components in Teradata, and these are the responsibilities. Okay. And we have seen the BINET and PDE as a message passing layer in between the two kinds of virtual processors called parsing engine and an AMP. And AMP is directly associated with its own virtual disks where it contains the data. And AMP will do the physical data operations, gives the result set back to the message passing layer. Message passing layer will merge the answer sets and give the answer set back to the user through the parsing engine. Okay, so let me stop here and see if you have any questions. Okay, there is one question here. If two users try deleting data from a table, then second user will get a table locked message. Does AMP know session user information? Yes, AMP would know that because it is provided by the optimizer. So all the sessions are maintained through the parsing engines. So when they give the request to the AMPs, okay, they will manage what to do, and AMP will do that operations physically so that the lock which is required for the second user will kept in a queue. So once the first user will perform the task of deletion or writing the data, and once the user releases the lock, then only the lock will be applied by the second user through the AMP. Okay, so the locking management, okay, when I say lock management, that everything, okay, keeping the locks in queue for the next users and then releasing the locks of the current users after the execution and then obtaining the lock of the next user, everything is managed by the AMPs. So let me unmute you all and see if you have any questions, because this is the major understanding what we require to understand the rest of the concepts. Okay. Accounting is a DBA concept, okay, as this is the responsibility of the AMP we have included here, but giving priorities and account strings and account string expansions, it is a concept in itself which takes 1 hour session. Okay, so I will explain you in DBA sessions. So accounting is to providing priorities for the users actually. And special utility protocols, as you know, in Teradata we have utilities like multi-load, fast load and fast export. Okay, all those protocols will be implemented physically by the AMPs to unload the data from the RDBMS and to load the data into the RDBMS. All such activities will be performed by the AMPs. Any other questions, anyone? In understanding of the internal architectural components and internal communications. Yeah, when we are creating the user, accounting is a different concept. When we create user, we'll associate an account also with the user, and this account indicates what is the priority of the user and how we can aggregate his operations, the account string expansions. That is a different concept. User is a different user and his priority is different account.
Hey Manohar, so when does the AMP will release the lock? answer until the answer set response has been given, or once AMP has done the processing?
Yeah, once AMP done the process of selecting the data, okay, when it gives back it to the message passing layer, it releases the lock physically on the table, and it will implement the second lock by the second user. So because the data is now with the message passing layer, it will merge and it will give back the data to the user.
So in the meantime, if the second user deletes something, the first user will get the wrong data by the time the data reaches the first user.
Yeah, so it is a sequential locking, right? So when the locks are not compatible, it will be in a queue and it will be released, and when it is released, the second lock applied, and yes, the deletion of the write would be happen by the second user. So it is as expected. If I am getting the data right now and in the next second if another user deletes it, yes, he deletes it, and when I refresh my query, I will get the new data. And who are not talking, can you please be on mute?
Manohar?
Yeah.
Manohar?
Yes.
Like for example, if the data has been dispatched between the two nodes, so who will decide to go? Like for example, I am finding, as per my request, I am finding the data in the two nodes.
Okay.
Okay?
Here.
Who,
Okay. Just a moment. In your question, I just wanted to correct one thing. Okay, when data is distributed across two nodes, when you are saying the data is distributed across the virtual disks. Let's suppose here 4 virtual disks, and in other node I have 4 more virtual disks. Okay, so the data is distributed across 8 virtual disks here, right? And the parsing engine will take care of dispatching the instructions to all the 8 AMPs. So all 8 AMPs would involve and work on their own disks. Okay, so even the data is distributed across multiple nodes, as you have the virtual disks across two multiple nodes as a single system, it will be treated as a single system only.
so parsing engine will take care of dispatching the request to the multiple nodes or multiple AMPs,
Yes.
right?
So when optimizer decides the data is existing in all 8 amps across two nodes, then it will instruct the message parsing layer to broadcast the message to all the amps, so that 8 amps will receive the message and 8 amps will work on their associated virtual disk and give the data back to the message parsing layer.
Okay.
Yeah, this whole diagram is one node I am showing. Okay, this is one node with the configuration of 4 amps and one parsing engine, but there could be multiple nodes, so multiple amps can be increased and multiple parsing engines will be increased, everything would be increased. So this diagram is for a particular node for our understanding purpose, how the communication happens within the architectural components of the Teradata. Okay, so this is for today. So far we have seen the benefits of the Teradata, and we have moved towards okay, what are the architectural components, what are they called, okay, what are the actual responsibilities of each and every component, and how the communication happens across the architectural components. Okay, so we move towards the data distribution part, how the data is distributed across multiple virtual disks evenly. So all these concepts we will see in rest of the classes. Okay. And who wanted to enroll and continue, please initiate their payments and enroll for this course so that you can continue for the rest of the sessions. Okay, so probably maybe day after tomorrow we may create a fresh link through which you can be logged in. So in order to get the all information, okay, please complete your enrollment processes. And if you have any questions, please leave your mobile numbers or be on the line. I will talk to you so that you can clarify your questions and decide on the enrollments. Or please leave your mobile numbers. I will call you back so that you can have a discussion, detailed discussion with me, and can clarify your questions. Thank you very much for joining today. You can drop off. for today's session.